Good morning. Today we're going to be talking about section 6.5 with square roots and cubed roots and nth roots. So if you look here on the examples that Miss Bayer has for our notes today, each of these just have a regular square root. When it gets to cube roots, we're going to have a little 3 here for these types of problems. Okay, and then as we move on, we're going to have ones that have different numbers. So that one has a 4, this one has a 5, and then this one also has a 4. So if we scroll back up to the top, the important thing to know is when we see a regular square root, that means two numbers that are the same that multiply to give us the number under the square root. So like for 25, we would have 5 times 5 is 25. So two numbers that were the same that you multiplied together were 5s to give you 25. So here, 32. So we're going to make a factor tree. And I use 2 and 16 because sometimes I just think off the top of my head, okay, I can cut it in half. Miss Bayer used 8 and 4. So it doesn't matter what numbers you choose, just as long as we all get to the same answer at the very end. Okay, so 2 times 16 is 32, and then 16 breaks up into 4 times 4, and those two numbers are the same. So I can put them under the square root. So I have 2 times 4 times 4, 2 times 4 times 4. There's my two numbers that are the same. Those cancel out and bump to the outside. So I've got my 4 here. So I have 4 root 2, but I still have to do something with x to the 8th power. X to the 8th power, since it's to the second root, so this one had the 2, the other ones had the 3, some of them had 4. What we're going to do is we're going to take x to the 8th power and divide it by 2. 8 divided by 2 is 4. So I've got my 4 root 2 from here. And since x to the 8th power, when we divided it by the number that's sitting out here, out on the ledge, which was an invisible 2, we're going to divide 8 by 2. 8 divided by 2 is 4, so I have x to the 4th power. Alright, so here is my final answer. Miss Bayer got the same thing. She just broke up her 8 and 4. I used 2 and 16. I showed you a little bit of a different way just because, or with these two numbers, just to show you that you can use different numbers and you'll still get to the same answer. Alright, so for 2, 16 breaks up into 4 and 4. There's our two numbers that are the same. So I've got 4 times 4, and we've got x to the 14th, y to the 21st. These two numbers cancel out and move to the outside. So I'm left with, why do I keep wanting to write a 2? So I'm left with 4 over here. And I've got 4 square root x to the 14th, y to the 21st. Ooh, this one's a little bit different, and that's okay. So here, since there's that invisible 2 sitting out on the ledge here, I can do 14 divided by 2, 21 divided by 2, and I've got my 4 stays the same, square root, I've got my little invisible 2 there, x divided by 14 over 2, x to the 14th power divided by 2. 14 divided by 2 is 7, so now I have x to the 7th power, and I need to leave myself a little bit more room. It's so weird making videos and watching my work through the screen. So weird. Alright, so I have y to the 21st here, right? So because there's that invisible 2 sitting out on that ledge, I divide it by 2. Y to the 21st divided by 2. 21 doesn't divide nicely by 2, but it divides by 20. So since 20 divided by 2 is 10, I can put y to the 10th power. And how many am I left over with? Well, 10 times 2 is 20, and I need 21, so I have y to the first power left under the square root. And if you look at Miss Bayer's, we have got the same answer. Haha, here we are. So I'm gonna circle that. I need to like not watch my video as I'm writing this. My work is really sloppy. I'm sorry, guys. Okay, so this one, we've got an invisible 2 sitting out on the ledge. We need two numbers that are the same. Well, this multiplies into 4 times 2, and then 4 breaks up into 2 times 2. So I have a 2, 2, and a 2. And then I've got x to the 11th. Yeah, I'm going to write this off to the side so it doesn't get sloppy like those guys. And then that's x to the 11th divided by 2. So then I'm left with 2 times 2 times 2. Two things that are the same, that cancels out and bumps to the outside. So I'm left with 2 square root. This canceled out, so I'm left with a 2 here. But I have x to the 11th power divided by 2. So I know that 10 divides by 2 nicely. So 10 divided by 2 is 5. I just lost my page. Here we go. Okay. All right. So then, yes. So 10 divided by 2 gives me 5. So I can do x to the 5th root x. So then if I just combine them, I've got 2 x to the 5th square root 2 from here and x from here. So if we look at that, that's the same as what Miss Bayer has. Okay. Moving on to number 4. 12. I gotta make sure I can see my work and not look at the screen. Here we go. All right, 12 breaks up into 4 and 3, or 2 and 6, whichever. I'm gonna use 4 and 3, and then 4 breaks up into 2 and 2. So I've got 2, 2, and 3. So then we've got the square root of 2 times 2 times 3. Two numbers that are the same, bump outside. I've got 2 root 3. But then I'm just going to do it all like this because I feel like having it 2 separate places was a little bit confusing. So I'm just going to do it all under the same spot. Okay. So then I have x to the 21st and y to the 10th. And since this is an invisible 2 sitting out on the ledge here, I can divide by 2 and divide by 2. So then if I work with the x's first, I can put x to the, let's see, if we divide by 2, and 21 doesn't work nicely, but 20 divides by 2 nicely, and that's 10. And then 10 times 2 is 20, and we've got 1 here, so we've got x to the first power. That's done. And then y to the 10th divided by 2. Oh, my screen is blurry. 10 divided by 2 is 5, so this just simplifies to y to the 5th. And that cancels out. So under the square root, all we have is the 3x to the first power. So we've got 2x to the 10th, y to the 5th, root 3x to the first. Do I need to have the ones? No. Do I need to show all my steps? No, if you know how to do it in your head. And if you look, ours is the same as, oh, where is it? There it is, Miss Bayer's. All right, so the next one that we're moving on to, like I said, has the third root here. And I highlighted my notes just because I'm super cool and my printer doesn't work with my school computer. I have to handwrite each of these, which is okay. So I've got cube roots here for these ones. So our fifth example has a 3 sitting out on the ledge here. So that means I need to come up with 3 things to pull out. So if I have the 16th here, all I have to do is divide by 3, and 15 divides by 3 nicely. So I can do, well, if I do 15 divided by 3, 15 divided by 3, that gives me 5, right? Plus 1 more would give me that 16. So that means that my final answer is going to just reduce, and I have x to the 15th over 3, and then I also have x to the 1st divided by 3. So this reduces nicely into x times x times x. So here's my group of 3. That's probably super confusing that I wrote it that way. But 15 divided by 3 gives me 5. So I have x to the 5th power square root. Okay, so 15 divided into 3 groups. If I did 3 groups of x's until I had 15, there would be 5 of them. That's what I meant by this. So then over here, I have x to the 1st, because when I have 16 divided by 3, only 15 of them divide. 15 divided by 3 gives me 5. So this number is what I put up here, and then there was 1 left over, so I put that there. So if this confused you, don't look at that. I kind of want to redo that one. Another way that I could show you is 3 root, or the 3rd root of x to the 16th power divided by 3. That could be like 15 plus 1. This divides nicely, and I'm looking for that 3rd root, and 15 divided by 3 is 5, so I'm going to put x here to the 5th power here, and then since I have 1 left over, I have 1x that goes right there. That's my final answer. So if that makes more sense, do it that way. Number 6, again, we need to find things that break up into groups of 3. So I can take each of these and just divide it by 3. So I have 27 divided by 3. 27 divided by 3 is what? 9. So I can put 9 outside my root, and that canceled out super nice. And then I've got x to the 12th divided by 3. That gives me x to the 4th. I should probably have left a little bit more room. You never know what's going to come out and what's not. So this one is x to the 12th divided by 3. 12 divided by 3 is 4. And for this one, divided by 3, I know 21 divides by 3 nicely, and then that means I have 2 left over. So this one is, this and this is the same as this. So if I have y to the 21st divided by 3, that leaves me with y to the 7th. And because I have 2 left over, that's what goes under the square root, y to the 2nd. Let's see what Miss Bayer has here. That's number 6. Oh, I just scrolled up. Hold on. Where'd it go? Oh, that's day 2. We want day 1. Here we are. Yep. Number 6. Wait, why does she have... Oh, so she didn't divide it by 3. Well, 9 divided by 3 is 3. Oh, okay. Always good to double check your work. So 27. Okay, here we go. We just have to change. Wait. Dang it. Okay. Well, we did the fourth one right. This is so hard to watch videos and to look at notes and to write it at the same time. Sorry, guys. 12 divided by 4. Can I pause? Okay, we had to have an intermission. All right, so definitely don't take that number and divide it by whatever number's there. What we're going to do is we're going to always, always, always do a factor tree, because otherwise you end up having to redo it, just like how I did. All right, so 27 breaks up into 9 and 3. Sorry about that. 9 breaks up into 3 and 3. 3 times 3 times 3. And I've got 3 things that are the same. 3 times 3 times 3. Those 3's are the same. Remember, we're looking for 3 numbers that are the same. That goes on the outside. And then now I can do x to the 12th divided by 3 gives me, what did she do? Oh, x to the 4th is right. She just didn't write her answer. Okay, so we've got 12 divided by 3 is 4. X to the 4th, that number just needs to go down here. That's what screwed me up. All right, so we've got 3 x to the 4th power, because that reduces to a 4 here. And so that's done. And then we've got to do our y's. So that part is done. And then y, like I said, it's the same thing as 21 divided by 3 plus 2 gives me 23. And this is the same thing as y to the 7th. So we've got 3 x to the 4th, y to the 7th, square root. So we had y to the 23rd, and we did this up here, so that one is done. So we have this, so 21 divided by 3 was 7, so y to the 7th went here, and I have 2 left over, so my y to the 2nd goes under the square root. Whew, that was way better. Cool, and that's what Miss Bayer has. Okay, number 7. I'm gonna turn the page here. Okay, more cubed roots. Great, we also need more practice. All right, so we've got 54 here. 54, you can cut it in half, or you can do 9 times 6. Miss Bayer did 9 times 6. I kind of want to cut this in half just to, well, yeah, because not everyone always knows 9 times 6 is 54. So I'm going to divide it by 2. And 2 times what gives me 54? Well, half of 50 is 25. So if I have 25, and then half of 4 is 2, that gives me 27. So I have 2 and 27. 2 is done. 27 breaks up into 3 times 9. 3 is done. And we've got 3 times 3. So that is the same as, I'm going to zoom out a little bit here. We've got 2 times 3 times 3 times 3. So if you notice, since there's that third root sitting out on the ledge here, we're going to find 3 things that are the same. That cancels out. And what number do they have in common? 3's. So we've got 3 root 2. And I have to go back up here to these numbers. and I've got x to the 20th divided by 3, because there's that little invisible 3 sitting out on the ledge here. And 20 doesn't divide nicely by 3, but 18 does. So we're going to get rid of that, and we're going to do 18 divided by 3 plus 2. 18 divided by 3 is 6. So 3 stays the same. We've got the 3 that sits out on the ledge here. We've got our 2 left over from here. And I've got, what was this? The letter X. This part was the letter X. So 18 divided by 3, we've got X to the 6th here. And then how many are left over? There are 2. So I write X to the 2nd. So we've got 3x to the 6th cubed root of 2x squared. And that was our final answer here. Right here. Okay. Moving on to our last example of cubed roots. We've got 98, and just because off the top of my head, I don't always know what the perfect square is, so I'm going to just divide it by 2, and half of 90 is 45, and then half of 8 is 4, so that gives me what, 49? 2 is done. 49 breaks up into 7 times 7. And unfortunately, this doesn't have 3 numbers that are the same. So we're going to leave this as 98. And then, because like here, up here, we had 3 3s. So we circled that group of 3s and we brought it to the outside. Right? Just like how we have this. But down here, since there aren't 3 7s or 3 2s, it has to stay like this. So now we have x to the 15th. Can I divide it by 3? Yes. X to the 15th divided by 3 gives us 5. So I have x to the 5th, root 98. And then I still have this stuff right here. Ooh. That's what happens when I'm watching a video while I'm doing my work. So then I have y to the 28th, and we've got that invisible 3 that's out on the ledge. So 28 divided by 3, we have, well, we don't get a perfect number, so this is the same thing as y to the 27th divided by 3 plus 1. So that means I can put x to the 5th, and then we've got y to the 27th divided by 3, which should give us, what, 9? So I have y to the 9th, square root, that's done, plus 1 of my y's, y to the 1st. And that is, I believe, yep. Oh, wait, I forgot my 98. 98 stays under that square root because there weren't, I'm just going to write it off to the side here. It does, typically this always goes here, but I forgot to write that in. So, oops, come on. X to the 5th, y to the 9th, cubed root of 98y. So we got the same thing. I just forgot to bring down my 98. So again, always good to double check your work. All right, I'm going to finish up here with simplifying the nth roots. And I've got to find 4 things that are the same. So x to the 16th, I can divide that by 4. I'm going to divide this one by 4, and I'm going to divide this one by 4. So numbers, you always want to make a factor tree. Otherwise, you're going to screw up like I did on like number 6. And then letters, you just divide by that number out front. So now that we're on the nth root, we're not going to have a 2, we're not going to have a 3, we can have any number. So here, I'm going to work with this part first. 16 divided by 4 is 4, so I've got x to the 4th. And then here, that's the same as y to the 5th divided by 4, and then that part's done. You've got to always remember to write this number here also, because if you don't, then you're going to end up messing up somewhere, and you're just going to probably find a square root. So you got to make sure that you always write that number here, especially like on a test or a quiz. And then we've got z to the 6th divided by 4. So 5 doesn't divide nicely by 4. X to the 4th is going to stay the same. And we've got the 4th root. So now I've got y to the 4th divided by 4, plus 1 gives me 5. And then I've got z, and if I did 4 plus 2, that gives me 6. Divide that 4 by 4, and then that'll reduce nicely. So x to the 4th stays the same. And I've got the 4th root. And let's do this part first. So 4 divided by 4 is 1. So I've got y to the 1st power here plus 1. So I've got y to the 1st in here. And then for my z, I've got 4 divided by 4. I'm going to rewrite this. I've got x to the 4th, y to the 1st, 4th root, y to the 1st. And then this is the same, that part's done, as just z. 4 divided by 4 is 1. So I'm going to put z out here, z to the 1st power. And how many am I left with? 2. So I'm going to put z to the 2nd power. There's my final answer. That was number 9. Let's check what Miss Bayer has for number 9. Yep, same thing. Awesome, awesome. Remember, you don't always have to write that little 1 when something's to the 1st power. I do, just to remember that it's the 1st power. Okay? 2 more problems, and we will be done. Sorry, this one turned out to be a little bit longer, guys. All right, when I have something to the 5th, come on, focus. There we go. Something to the 5th root, same thing. Divide by 5, divide by 5, divide by 5, divide by 5. So I've got the 5th root of this first one here. 10 divided by 5 is 5. So I have 10 divided by 5 is 2. So I have x to the 2nd. That's done. Now I've got y to the 27th divided by 5. 25 divides by 5, but 27 does not. So I have y to the 25th plus 2. Take that and divide that by 5. And then I have, that's my y's. That's kind of done. Then I've got z to the 30th divided by 5. That one reduces nicely. I'm just rewriting that. And then this one is m to the 15th plus 1. Because 15 and 1 give me 16. 15 divides by 5 nicely. So now I can simplify that a bit. So I've got x to the 2nd. Let's do this one. So I've got 25 divided by 5, which is 5. So I've got y to the 5th. And we've got the 5th root. And that was a y. I need to have my 2. So I have y to the 2nd. And then that part is done. I need to leave like a space in between every single one of these. This is turning out to be so much work. This one reduces nicely. Z 30 divided by 5 is, that should be 6. So then I can write z to the 6th power. And now I have my m m to the 15th. I need to rewrite this because I don't have enough room to write that part down here. So I've got x to the 2nd, y to the 5th, z to the 6th, and this one, 15 divided by 5 is 3, so I'm going to have m to the 3rd, and that is the 5th root. That goes away. I had y to the 2nd left under here, and now I have m to the 1st because there's 1 left over here. So if we check that with what Miss Bayer has for number 10, she did not write her final answer. So we've got our x to the 2nd, y to the 5th, z to the 6th, m to the 3rd, 5th root. We've got y to the 2nd, which she has under here, and m to the 1st, which she has under there. We just didn't write the final answer part. That's okay. All right, number 11. We're doing it right. Number 11. Remember, in numbers, we always have to draw factor trees because you mess up if you don't. Or at least I do. 32, you can break up into 4 and 8. Maybe you found something else. I'm going to do 2 and 16 because half of 30 is 15. And then half of 2 is 1, which gives us 16. 2 is done. 16 breaks up into 4 times 4. Oh, someone's calling me. Shoot. Okay, don't want to answer. I do want to answer, but I can't. Okay. This is 2 times 2 times 2 times 2. And that is 1, 2, 3, 4, 5. 2's under the square root, but we're only looking for 4. 2 times 2 times 2 times 2 times 2. Here's 4 numbers that are the same. That cancels out and moves to the outside of the square root. And then we've got, I wish I had like another hand or another arm. Be able to like hold stuff better. Okay. Sorry, this is so shaky. All right, x to the 17th. Remember, we got to put this little 4 here, because if you don't on a test or a quiz, it's wrong. But really it is. So we've got 17 divided by 4. 17 doesn't divide nicely by 4, but we'll fix that in a little bit. So this part is right here. This part we're going to put over here. And we've got y to the 28th divided by 4. Okay. Yeah. So let's zoom out just a little bit. There we go. Our 2 stays the same from up here. And then if we're looking at this one, that is the same as, hold on, this 2 stays here because he's left under the square root. And then I've got x to the, 16th plus 1? Because 16 divides nicely by 4. And then y to the 28th divided by 4. That one reduces nicely also. So let's do this guy. And then this reduces to x to the 4th, because 16 divided by 4 is 4. So we've got x to the 4th. And then this one's left over. That's gone. So now I have 2. X to the 4th. Oh, we need our 4 here, otherwise it's wrong on a test or quiz. More specifically, the final answer, but if I don't write it then here, then I probably won't write it in the final answer. So this simplified to x to the 4th, which is here. I have 1 left over, so I have x to the 1st. And then here, that divides nicely. 28 divided by 4 is 7. So I can put y to the 7th. That should be our final answer, minus the fact that I forgot to write my 2 again. So I'm just going to write it here. And that is what Miss Bayer has. Hopefully that makes sense for you guys. I know I went about 10 minutes over on this little video here. We're trying to keep our videos to less than 25 minutes. but you guys also have the option to fast forward. All right, if you have any questions on any of this, let me know. It looks like Miss Bayer also has the homework posted for 6.5. So we're going to look at 6.5 homework worksheet for today. All right, we're going to try and have 3 lessons each week. Probably Monday, Wednesday, Friday. But I think we're going to post it all on Monday or the beginning of the week. So that way you have all the days to work on it. Good luck. If you have questions, let us know.